So without further ado, let's get started with the sky this month, presented by Arnold Brody.
Thank you, Paul, and hi, everyone. For the sky this month, the month is actually the next 4 weeks until we have our next online meeting on July 15th. We'll take a look at some SpaceX news, some upcoming launches, and then we'll get into observing. Now, as everybody probably knows, the SpaceX Dragon Demo 2 carrying veteran astronauts Bob Behnken and Doug Hurley took off from Florida on May 30 and docked with the ISS the next day. The Dragon was the first commercial spacecraft to carry astronauts to the ISS, and the first crewed spaceflight to launch from the US since the shuttles were retired in 2011. Bob and Doug named the capsule Endeavour, in part because they both took their first space flights aboard the retired Space Shuttle Endeavour. The Apollo 15 command module that orbited the moon in 1971 was also named Endeavour. Meanwhile, Boeing has decided to refly its Starliner passenger spacecraft without a crew this fall to dock at the ISS. They tried back in December, but that test failed when the Starliner had trouble reaching orbit. It consumed far too much fuel and didn't have enough to attempt a rendezvous, so they will try again this fall. Here are a couple of great shots by Reza Mohammed and Richard Prentice of Endeavour, the smaller dot or line and the ISS crossing the sky the night before Endeavour docked with the ISS. 4 days ago, SpaceX launched 58 more Starlink satellites atop of Falcon 9, bringing the total launch so far to 540. The next 60 are scheduled for launch a week today. And SpaceX is developing a rocket called Starship that will launch up to 400 satellites at one time. In total, 12,000 Starlinks are planned for deployment, with another 30,000 possible later on. Starlinks from the first 8 launches are so bright they ruin scientific deep space imaging, as you can see here. Researchers may lose up to half of their images. SpaceX painted a Starlink dark gray to see if that would help. It's too dark to be seen naked eye, but it's still found in images of deep space, so that idea didn't work. So that the Starlinks in last week's launch wore sunshades. All future Starlinks will wear them too. They block all sunlight, so the satellites are then invisible. And this might be a new problem for those monitoring stars for dips in magnitude. Basically, we're trading white lines for black lines. And SpaceX is not alone. Others like Web1 and Amazon and China too, they want to fill the sky with their own internet beaming satellites. And I don't know if they're going to be bright or if they're going to be wearing sunshades. I don't know, but low Earth orbit is getting pretty full now. As for upcoming launches, a number have been rescheduled after the interruption caused by the COVID-19 pandemic. Here are the next 4, all in June, with launches in China, French Guiana, and 2 in Florida. A number of July launches have yet to be assigned dates, but one launch in July with a date is the United Arab Emirates Mars mission on July 14, with liftoff from Japan. Later in July, there will be launches to Mars, including NASA Perseverance rover and China's Tianwen-1 Mars lander. The Mars launch window opens in July. You can go to Spaceflight now to keep an eye on the launch dates. So I'd like to now turn our attention to observing. The summer solstice is just days away, and the year's nighttime hourglass is squeezed to its narrowest. And those of us near the 40th parallel have only 3 hours and 40 or so minutes of true night on or near solstice. Although the solstice has the shortest night, we can at least look forward to nights growing longer the rest of the year. By July 14, night is 40 minutes longer, but you can observe brighter double stars and planets during twilight. And for Mercury and Venus, you actually have to catch them in twilight. At the solstice, the sun will reach 69 degrees high at local noon, at our latitude of 44 degrees. And Earth reaches its fullest from the sun on July 4, 152 million kilometers away, instead of the typical 150 average. And as of tonight and all of next week, we have dark skies with the new moon this coming weekend. And then a photogenic first quarter moon with the X and V occurs the following Sunday. The weekend after that, you can watch the full buck moon rising, so named because this time of year, buck deer antlers begin to grow. It's also called the thunder moon or the full hay moon. And then darker skies will eventually return by the end of that week. Throughout the summer, the darkest nights will be mid-month. So now that we know when it will be dark, let's see what's happening with the solar system working our way out from the sun. Active regions associated with solar cycle 25 have been appearing on the sun over the last few months. And magnetogram images by the Solar Dynamics Observatory on the left, they show an active region with cycle 25 polarity. And if this cycle 25 activity continues unabated for 6 months, the NOAA will then say that cycle 24 ended 6 months earlier. In other words, the end of a cycle is determined after the fact. This new activity means the sun has become an interesting daytime target again, with sunspots and prominences returning. Cycle 25 sunspots will appear in solar mid-latitudes initially, like the picture we see here. And they will drift up towards the equatorial region over the next 10 to 11 years, forming what is known as the butterfly diagram, as seen here from the previous 2 solar cycles. Notice that the overlap of spots between the two, that there is an overlap of spots from the 2 cycles, so there is no clear break between them. This renewed activity and with it a likely increase in solar flares, that means we could be seeing more auroras again, like this display captured by Sailu Nemina up at the CAO a couple of years ago. If you'd like to receive aurora alerts in your inbox, visit the NOAA subscription service page and register for the alerts that you want. As you can see here, I'm registered for space weather advisories, which come every week and on any day if something significant occurs. An example of an advisory email is on the right, in which there was nothing happening at the time. I'm sure that's going to change pretty soon. On to the moon. On June 28, we can see or image the lunar X, which is a result of sunlight and shadows on the rims of the Longinus, Lacaille, and Purback craters. The X is visible for a few hours just before first quarter, slightly below the moon's equator. At the same time, a lunar V can be spotted further north up the terminator. It's the result of sunlight and shadows involving Euclid crater and a few other small ones. In the middle diagram, the yellow dots show where and when the lunar limb is tilted at its maximum towards us due to libration. On July 4, we have a good opportunity to explore the circular Mare Smithy peeking around the moon's eastern limb. And at perigee, the angular size of the moon is almost, not quite, but close to 10 degrees larger than at apogee. Well, there are some interesting moon events over the next 4 weeks, starting in just 2 days. If the pre-dawn sky is clear on Friday, and I think it will be, we can catch a thin crescent moon and a similarly thin crescent Venus rising only 10 arc minutes apart for those of us in the Toronto area. Both can fit within a telescope's low power field or in binoculars. And high magnification of Venus shows its crescent phase imitating the moon, which makes sense since the sun-moon observer angle is essentially identical to the sun-Venus observer angle. So it would make sense they would both have the same phase. Now, if you intend to photograph the pair, please be sure to position an umbrella or other shade to block the nearby rising sun for safety. The moon will actually occult Venus for observers in eastern Canada and north of a line running through Europe and Asia. Here's a close-up showing the occultation zone in eastern Canada, eastern New York, and the New England states. Between these two yellow lines, the moon will rise with Venus behind it, and you can then watch Venus reappear in daylight. Visit the IOTA website for the timings where you live. And now 2 days after that, an annular eclipse sweeps across southern Asia, northern India, and eastern to central Africa on Sunday. The moon's angular size will be just a little bit too small to completely cover the sun, resulting in a ring of fire in the sky. We can expect live streaming of the eclipse. We can check out YouTube for those. And if you catch it, it'll probably be around midnight our time, depending on where exactly along the eclipse path the broadcast originates. On June 29, the moon occults 95 Virginis, magnitude 5.5. It occurs around midnight, depending on your location. The timings shown in this animation are for my home in Whitby, east of Toronto. For those living further west, the occultation happens earlier. And there will be a partial penumbral lunar eclipse on the night of Saturday, July 4 and into Sunday at the times shown here. Now, penumbral eclipses of the moon are very hard to detect. There's not that much darkening. And the previous full moon in June also underwent a partial penumbral eclipse as the moon passed through Earth's northern penumbral shadow. In between these two near misses of the Earth's umbra, the new moon of June 21 crosses the ecliptic right on the node on the opposite side of the sky, of course, producing the annular eclipse we just talked about. On to the planets. Looking down from above the sun's north pole, we see the relative positions of the inner four planets as of tonight. If we treat this white line as the horizon for our stargazers, the sun is about to rise. They can see Mars up fairly high, so it must have been up for hours, and Venus appears very close to the horizon, having just risen before the sun does. It's now about an hour later, and stargazers on the other side of Earth have just watched the sun set, and for them, Mercury is visible low in the west, about to set soon itself. And here are the inner planets on July 14. Mercury has traveled about a third of its orbit to the other side of the sun from our perspective. Now all three inner solar system planets are visible during some part of the night or pre-dawn. Let's take a closer look. As we just saw, Mercury is visible very low in the west after sunset tonight. Its orbit is taking Mercury to inferior conjunction. It will pass between us and the sun on June 30. Now, if you have an unobstructed or elevated view to the west, you can pick out the magnitude 2.2 speck of light in binoculars after sunset the next couple of days. But do wait for the sun to set before trying, of course. By this time next month, Mercury has swung to the other side of the sun from our point of view and is now rising in the pre-dawn spot than it was back on June 17 because it is slightly higher on this date and hence further from the sun and around twice as bright. Venus just finished a great show as the evening star this past winter and spring, and now it's west of the sun, what we call the morning star, and for the next 4 weeks, it will be climbing higher. Tomorrow morning, Venus will be just 6% illuminated, but a brilliant magnitude negative 4.3 because it's relatively close to us, giving us a larger surface area. It's almost a full arc minute in size, over 50 arc seconds. By July 14, Venus has come close to the anse of its orbit, which it will reach on August 12, and has dropped in angular size to about half an arc minute, though slightly brighter at minus 4.5. This would be a good time to try taking an image of the thin crescent, especially when our atmosphere is calm before dawn. With luck, you might capture the crescent Venus like Rick Foster did on May 13, when it was still east of the sun. This image is all the more impressive when you consider the turbulent air close to the horizon that Rick had to deal with. Well done. Now, on to Mars. In mid-June, Mars rises around 1:30 in the morning, climbing to around 30 degrees high in the southeast by the end of astronomical twilight, which occurs around 4 a.m. In the pre-dawn, the air is typically very calm, having had all night to settle down, providing good seeing needed for planetary detail. And being 30 degrees up, Mars is above much of the obscuring atmosphere, improving our chances of seeing it hold steady. Now, the amount of atmosphere we look through depends on the altitude of the object we're viewing. With Mars 30 degrees up, we're looking through two air masses, about 1/3 less than when just 20 degrees up. That's why it's so important for planets to rise above 20 degrees to get an opportunity for a decent look. We are at the start of the great apparition of Mars for 2020, and we will come very close to Mars at its opposition in October. Over the next 4 weeks, Mars drifts 1 hour of right ascension from Aquarius to Cetus. And as of the 14th of July, Mars will be 13 arc seconds wide, getting brighter now at negative 0.7 magnitude and 85% illuminated. These are photos of Mars taken by fellow club members during the last approach in opposition of Mars in 2018. They have been posted on our forum astrophotography section where you can read more about them. As for observing Mars, you will want to use as much magnification as your telescope and local conditions will allow. Now, rule of thumb is a telescope can theoretically achieve 50 times magnification per inch of aperture. So if you have a 4-inch scope, you can push it to 200x. If you have an 8-inch, you could push it to 400x. And you may try using an eyepiece that achieves your maximum theoretical magnification for your scope, because Mars will be up high in the pre-dawn sky when the air should be steady. And so give it a try, and if it is steady, you'll get some great views. Otherwise, you may have to back off to a lower power eyepiece. And using color filters can enhance certain features. Orange increases contrast between light and dark features, and that will also penetrate hazes and most clouds. Yellow brightens desert regions and darkens bluish and brownish features. Red enhances fine details on the surface by darkening the non-red areas, and light green enhances frost patches and polar caps. Finally, blue filters may show you clouds and limb haze. So if you have these color filters or decide to get them to maximize your viewing of Mars this summer, remember you can also use them for viewing Jupiter and Saturn as well. Mars passed through its equinox in April, autumn for the north, spring for the south. Its southern hemisphere is tipping towards the sun and us now. Maximum tilt, the start of summer for southern Mars, occurs on September the 2nd. So as we observe Mars this year, we will be watching its south polar cap shrink. On our way to the gas giants of the outer solar system, we pass through the asteroid belt where 5 of the brightest are approaching opposition, namely Alette, Antigone, Lydia, Herculina, and Palais. And here are the paths they will take across our sky the next 4 weeks. The location, date, and magnitude at opposition are marked for each of the asteroids. I think the brightest one is Herculina. It reaches 9.5. And here's an example of how far Herculina travels at opposition. The field of view here is about 1/2 a degree. And if both of those nights are clear, and if you take images of that area, you could try your own blink test to find the asteroid later. Now we've reached the outer solar system, and here are the positions of the gas giants as of tonight, and 2 dots next to the sun, showing Earth's position tonight and on July 14. Here's a horizon line like we used earlier with the inner solar system. For those on the night side of Earth, all 4 outer planets are visible, at least for some portion of the night. And here's another line representing the location, I should say the horizon, for people watching the sunset in their western sky on July 14. If they turn around and look east, they will see Jupiter rising. In other words, Jupiter will be rising at opposition that night, rising as the sun sets, with Saturn to follow a week later. Jupiter rises at 10:47 tonight, so after the show, you can get outside and take a peek. And it will cross the meridian 6.5 hours later at 3:17 in the morning, when the sun is still 17 degrees below the horizon, so still quite dark. At that hour, our sky should be calm, having settled down all night, and that should give us good seeing so we can pick out details in Jupiter's cloud bands or capture excellent photos like the one here by Rick Foster. As for colored filters, a rule of thumb is to choose a filter with a color opposite that of the feature you want to see. So to enhance the great red spot and the reddish-brown equatorial bands, you can try a blue filter. Blue filters block some of the red, darkening the red spot and equatorial bands so they stand out in greater detail. In larger telescope, or in greater contrast, I meant to say. In larger telescopes, a red filter can bring out projections and festoons along the edge of the equatorial belts, and a light yellow filter may enhance the polar regions. It takes Jupiter 10 hours to rotate, so there's an opportunity to observe or time-lapse record its rotation at or near opposition. But being summertime, we only have a few hours of night, so we can only catch part of that rotation. Shadow transit across Jupiter by its large Galilean moons are fun to observe, even image. Here's a depiction of how the transit of Io and its shadow will appear at 1 a.m. Eastern Time on June 30. Cal Sky predicts the great red spot will transit that morning at 2 a.m. So I doctored this image to place the GRS where it should be at 1 a.m. Jupiter will be 22 degrees up then, so we're going to need some good seeing for a decent view or astrophoto. And here's Jupiter's retrograde path as Earth overtakes it in our race around the sun. The upper left oval shows where Jupiter is tonight. The one in the center is where it will be at opposition, and it's interesting to note that when at opposition, it is halfway between the extremes of its retrograde path. And here's a special bonus for anyone with a 10-inch or larger telescope, a chance to spot Pluto with Jupiter's help. Jupiter and Pluto had 3 conjunctions this year due to Jupiter's retrograde motion. The second of the 3 occurs on the night of Monday, June 29, and on through midnight, when both planets are at right ascension, 19 hours and 44 minutes, shown here. The declination lines in the grid are 10 arc seconds apart. So if you have a 10-inch or larger telescope on an equatorial mount without GO2, you can try spotting Pluto, which reflects sunlight at a feeble magnitude, 14.3. First, center Jupiter in a high-power eyepiece, then slew south 40 arc seconds. Pluto is now in your field of view, but it will be low, and it will be faint. So I wish you good luck in finding it. On to Saturn. Saturn rises tonight at 11:04, just 17 minutes behind Jupiter, and crosses the meridian 17 minutes behind Jupiter as well, around 3:44, with the sun still very low. So it will be a good opportunity, again, with steady air that we should have in the early morning hours, and it will give us sharp views of the planet and its rings. And maybe you'd like to give sketching a try. The rings are tilted around 21 degrees to our line of sight, nearly hiding the southern pole. This summer and fall, the tilt increases another 1.5 degrees, almost completely hiding the southern limb. And the diameter of the outer A ring is 2.6 times that of Saturn itself. So when Saturn reaches its greatest angular size of 18 arc seconds around opposition, the rings will extend 43 arc seconds, almost as wide as Jupiter at 45. And here is Saturn's path in the sky. It's also going through retrograde now. And the portion of Jupiter's path that is in this image, I colored it blue to be less confusing. And here we see the position and appearances of Uranus and Neptune on July through my reporting period. These planets rise in the morning, Neptune around 1:15 and Uranus at 3 a.m. That's the beginning of astronomical twilight, and neither planet reaches the meridian during nighttime, so this is not a good time to see it. Neptune reaches opposition in September and Uranus a month later, so late summer and early fall will be the prime time for viewing these little blue dots. Moving on to comets, of the 8 brightest comets listed in theskylive.com, only 2 are up during the night in the northern hemisphere at this time, C 2017 T2 and C 2019 Y1. The other 6 are currently visible from the southern hemisphere, and some will cross the ecliptic and become visible in the north. I suggest you visit theskylive.com/comets if you want to stay current on these bright comets and find out when some of those may be crossing the sky coming north. The 2 comets that we see here are fading. A large aperture, moderate to large aperture telescope would help. Of the 2, the Pan-STARRS is still fairly bright at 9.0, so you may be able to catch that without too much trouble. There are no meteor showers at this time. The next one is the Southern Delta Aquarids in late July. And on to deep space. Here's our sky 4 nights from now on the new moon Sunday at 11:30, the true start of night. Now, this would be your last weekend for targeting the galaxies in the Virgo, Leo, Coma Berenices area until next spring. And west of the meridian are a handful of globular clusters. Messiers 5, 3, and 53 are all high up, providing excellent views. Even higher are globular clusters M13 and M92 as they pass overhead, touching the zenith or nearly so, giving you a chance to observe or photograph these dense balls of stars through only one air mass. Like Sailu did when taking this detailed image of M13 up at our Sioux Lore Observatory last June. And here's the sky looking south on the night of July 14-15, when Sagittarius and the Milky Way's nucleus cross the meridian at the start of night. The Sagittarius arm of the Milky Way, you can see it rising here from the nucleus, is stretching overhead up through Cygnus the Swan and on to Cassiopeia. This is prime time for the globular clusters that form a halo around the Milky Way's nucleus, and treasures of all kinds that are embedded along the Milky Way, such as planetary nebula like M27, the Dumbbell Nebula found in Vulpecula, emission and reflection nebulae like the Lagoon Nebula, 6 degrees north of the spout of the teapot, and the Trifid Nebula, 1.2 degrees further north, or open clusters like M29 in Cygnus, or double stars like colorful Albireo, or the challenging double-double Epsilon Lyrae that are barely separated here in this photo. You will have actually a good opportunity to try splitting the double-double because they are passing very close to the zenith this month. And so you're looking through, again, just one air mass to try and split them. And I think it's a bit ironic that all of this wealth of deep sky objects are up during the shortest nights of the year. But at least it's not frigidly cold. As you wage your battle with biting insects while trying to enjoy the stars this summer, you might want to be on the lookout for bugs in space. I have 4 for you, starting with Caldwell 19, the Cocoon Nebula, and emission nebula surrounding newborn stars. Found in Cygnus, flying high in the east, magnitude 7.2 and 20 arc minutes wide. Not quite as big as the full moon. It's 2,500 light years away. The second is a very faint and it may be difficult to find. It's NGC 6537, the Red Spider Nebula, although spiders are arachnids, not insects, I know. But found in Sagittarius, it is magnitude 13. So that's going to need a large telescope to see optically. It's probably best captured by camera. A companion star, or maybe it's magnetic field lines that are forcing the expanding nebula to take on that two-lobed shape. The third is the Bug Nebula in Scorpius, also known as NGC 6302. It's sometimes called the Butterfly Nebula, but I'm saving that name for the next slide. It's a bipolar planetary nebula. It may be a challenge due to its low declination. For us, it only reaches about 7 degrees high at best. An elevated viewing location will help. Aim your telescope 4 degrees west of Lambda Scorpii, the scorpion stinger. The bug will look like a slender, fuzzy streak in a 150 millimeter telescope and more like an hourglass in scopes 200 millimeters and up. The final bug in space is the Butterfly Nebula embedded in IC 1318, also known as the Satyr region in Cygnus. It rides very high in the sky this summer. There is at least one other butterfly nebula, NGC 2346, but that is currently lost in the sun's glare in Monoceros. IC 1318 lies 850 light years away and glows weakly at magnitude 14.9. This is definitely an astro-imaging challenge, well executed in this image of the Satyr region by Adrian Aberdeen. I would like to thank our club members listed here on the left for their astro photos. They are excellent. And that's a wrap, Paul. Enio, are there any questions?
So, we have one question from Eric Briggs. Is Arnold using Starry Night? There's a text file in Starry Night that can be used to update the Great Red Spot positions to keep it current.
Yes, as you see on the right, I was using Starry Night Pro, both 6 and 8, Stellarium, and Virtual Moon Atlas to help with the images in the show. Thank you for the tip on updating, and I'll try that to see if it works.
And while the question was answered in the chat, Ashita Parek is asking, is it possible to see the Milky Way this month from the Long Sault area near Toronto?
I think so. I have seen it from Long Sault. I've also seen it on a very good night from Glen Major Forest. So I think if you get out, and if it's a dry night with no haze, that would help a lot. Then yes, I believe you will be able to see it.
And Eric adds to his question, the file is called jupitergrs.txt.
Thank you.
Okay. Any more questions, Enio?
That's it for now.
That's it. All right, perfect. So Thank you very much, Arnold, for a very thorough presentation. Well done, and I appreciate you taking the time to prepare for this and sharing it with us. Thank you so much.
Well, thank you too.